doing another solid of revolution, and we will be doing a new method, which what happens when you take a curve, we'll say it goes like that. Oh, what's going on? Like this, which we don't really have to name the function of it because we're not, this is just random curve just to explain the idea. And then we have maybe a curve like sine of x, something like that. A bad curve, but whatever. And this extends on. So what happens when we use the washer formula, or not washer, disk formula, to rotate this curve around, and also this curve around, and then subtract out this curve, so we can get the volume of this curve right here, the space in between here, rotated around here, which now it's all again messy. But what happens when we try and find the volume of this when it's rotated around here? Well, it's called the washer method, and it's like to the disk method, but has a few more requirements to it. So let's write down the formula for it. We have the volume equals same pi as the disk formula, A to B. Now we can write the washer method because we know what it's called. Okay, so this is the washer formula. Well, it's not done yet, and instead of being f of x squared, it's actually f of x squared minus g of x squared, which is pretty much just the disk formula of this curve. So all this space rotated, and then all this space right here rotated, and then you subtract the smaller one from the bigger one, and you get this extra volume right here. So now it's getting crazy again. But so there we have it, and so it's not too hard to see where the f of x squared minus the g of x squared comes from, because it's just subtracting disk formulas, except within the integral before you integrate it. So, and that's dx. An example, we can do, I don't know, we can make f of x, we can make it the square root of x, and g of x we can make, I don't know, so here we're going to make something that goes along here. We'll say the curve, I don't know, x squared minus 5. So it'll look like this, it'll look like that. So we're trying to find the volume. No. Let's change this around. We'll keep the square root of x. We want to keep it above the x-axis because we're rotating about that, and it gets all weird when you go into the negative x-axis. So we'll keep it above, and instead we'll put plus 5 here, and then g of x equals x squared, just x squared. So it'll look like this. It'll go like that, and like that, like this, So we're subtracting this little area from all the area here, and in turn, we're getting this rotated around the x-axis. And we'll just keep this shaded region here. We'll go with white, and we're trying to get this rotated around. Okay, so how are we going to do this? We're just going to plug it into the formula. So, change up the colors. We're going black and white here. Now I can, oh, there we go. So the volume equals pi times, and we'll say from 0 to maybe 2. That may look good. Let's make sure it's not already crossed. 2 is 4. Square root of 2 is around 1.56, whatever, 1.6 maybe, plus 5, yep, that's above 4. Okay, so we're finding maybe right here to where they go to. Okay, so from 0 to 2, and f of x squared, I chose the square root on purpose because I wanted even numbers, but you know what, I added 5, so now, actually, you know what, I'm going to the square root of, we'll make from 0 to 1, yep, you know what, I'm gonna change this, and I'm just gonna have the square root of x and x squared from 0 to 1, because that's gonna make, that's where they intersect, because at x equals 1 and x equals 1, square root of, or square root of 1, x squared, whatever, it's still going to be 1. So it's going to look like, it somewhat will look like this, but at the intersection here, at x equals 1. So this will be much easier. So square root of x, because I'm trying to make this easy, because when you add the 5, then you got to do plus 10 square root of x plus 25 and plus x, and it gets all messed up. So we'll square root of x squared is just x, and then minus g of x squared. G of x squared is x to the 4th, and that's dx. And we'll just take the antiderivative of this, and it equals pi times the integral of x is just x squared over 2. X to the 4th, integral of that is x to the 5th over 5, but there's a negative, so negative x to the 5th over 5. And that is from 0 to 1, we said. And since it's 1, it's just going to be 1 squared is 1 over 2 is 1/2. Let's keep the pi in there, don't want to forget that. So we'll go 1/2 minus 1/5, because 1 to the 5th power is still 1. 1 to the any power is still 1. So we'll go minus 1/5. And we don't have to do 0 because 0 squared over 2, we already know that's 0. 0 to the 5th power, that's already 0. So we'll just keep like this. And let's take a common denominator for 1/2 of 1/5. 2 times 5 is 10. So we're going to pi times 5/10 minus 2/10 equals, and we're on the home stretch, and we have times 3/10, and now it equals, let's do a nice orange color, 3 pi over 10. So that is the volume of this space, or nope, not this space, this space right here, when it's rotated around the axis like that. And there we go. But also, which I'm not going to do an example for this, but also with the washer method, you can switch it around and rotate about the y-axis with functions of y and have limits on these integrals of y and dy. So it's also like saying pi, the integral of a to b, which would be heights here, not little lengths here, but heights, times f of x squared. No, sorry, f of y squared. So it'll be a function maybe x equals the square root of y. That would look like, I don't know, x equals 1, y equals 1. Right there, x equals 2. No, x equals 4, y equals 2. So x equals 4, y equals 2. It'll look like this, I believe, maybe. No, probably look like that. I don't know. Doesn't really matter. But, and then minus g of y squared dy. So that's another way of doing it. So if you ever have to rotate about the y-axis with washer method, go ahead and use y and dy. So